I'm just going to walk you through the assembly process of one of our enail units. I think it goes without saying this type of device is more of a niche product and is not something that's going to sell tens or hundreds of thousands of units. So some different decisions go into assembling this type of electronic device than a more high volume one. Because the first manufacturing run of this revision is something like 300 units, it doesn't even make sense for us to waste time programming a pick and place machine to assemble these for us, so we're just going to do it by hand. Normally we would use a frame stencil that will do 9 boards at once, but for the purpose of this video I'm just going to do 1 board. The process is pretty simple. I'm just going to align the stencil with the contacts on the board and apply the solder paste with a spreader tool. And then we could take a quick look to make sure we didn't mess up, and then we can move on to placing the components on the board. Now that we have the solder paste stenciled on, we're going to use some tweezers to put all of the surface mount components in the correct positions on the board. Some of the larger components you see are the microprocessor, the power regulator, and the thermocouple chip. The temperature chip on this board is a little better than the one we used on last year's model. It has some extra filtering for power line noise, which is supposed to help with temperature stability if you have dirty power in your house. The 2 smaller square chips are the accelerometer and the sound amplifier chip. Another issue we have with being a small run device manufacturer is that because we don't buy tens of thousands of these parts at a time, we actually had to change the accelerometer we spec'd out from development to production because the original part we chose is now out of stock until May 2019. All of this empty space on the left side is for the high voltage components, and those will get installed in a later process. Now we'll put the board into the reflow oven so all of the surface mount components can get soldered on. Now that all the surface mount components, apart from the micro SD port, are soldered on, we can do all the through-hole components. These get installed with a normal soldering iron. If you follow the Fuck Combustion website at all, you might be aware we had to make a slight revision to our board for certification. So because we had to do that anyways, we added this port for future color screen update without requiring a new board, or for anyone that wants to mess with or modify their device. One downside of using white circuit boards, even though they look really nice, is that you have to be quick when you're working on them because you can turn them yellow from too much heat. It doesn't look like we need to fix anything else from the reflow oven, so all we have left to do is install the micro SD port. We're going to use the hot air tool to do that. So I've already stenciled on the solder paste on the micro SD port, and I've tacked down the 4 corners with a normal soldering iron to make it a little bit easier to install. And then we're going to use the hot air tool to reflow the pins on the SD card port. So now that the board's completely assembled, I'm going to put an SD card in it. The only thing that gets stored on the micro SD card are files that you download to the unit. I know you guys had some concerns with some other units burning up the SD card by doing too many write cycles and making the units non-functional. The only thing that we store on the SD card are files that you transfer to your unit, like sound files or anything that you download through our user portal. If you have a sound theme with MP3s or something like that, those will get stored on the SD card. But all of your settings like your Wi-Fi password and your auto off timer or temperature set point are stored on the board itself. So even if you remove the SD card completely, your unit will still work just fine. Once the board's installed in the bottom case, we're going to hook it up to the computer and program it, which just takes about 30 seconds. Once that's complete, we're going to plug the remaining headers in the board and put the 4 screws in the case and hook this thing up and hope that it works. Once the unit boots up, it will just have default settings on it, so it should be set to 300 degrees Celsius and should just have basic PID settings, so it will probably overshoot by 20 degrees or so. From here we can set up Wi-Fi and start customizing a heat profile, which we'll have in a coming video in the next couple days. Provided everything works during testing and calibration, we would install the knob on the unit and then we'll send it off to the laser engraver to put the logo and serial number and FCC numbers on the bottom, and then it will get shipped out to one of you guys.